In this video, we're going to look at a couple of properties of matrix multiplication. One property that matrix multiplication does have, and another property that it does not have. We're actually going to start with the one it does not have. So if you think about multiplication of just regular numbers, let's call them A and B, then it does not matter the order you write the numbers from left to right. For example, 3 times 7 and 7 times 3 are both going to give you 21. The order they're written from left to right doesn't matter, and we call that property commutativity. So we would say that multiplication of numbers is commutative. But that's not true for matrices. In general, if you change the order the matrices are written from left to right, you'll get different results. A times B and B times A are usually not equal. Sometimes they are, but that's the exception rather than the rule. So for example, let's say that I have these matrices 1, 2, 1, 3, and 0, 1, 1, 0, and I multiply them together. So if we follow the procedure for multiplying matrices, we end up with the product 2, 1, 3, 1. But now let's just switch the order they're written. So I took the matrix that was on the left and put it on the right, the matrix that was on the right and I put it on the left. And then if we carefully follow the correct procedure for multiplying those matrices, we get a result that's different. These two matrices are not equal. So, in general, changing the order the matrices are written from left to right changes the result of the product. In fact, if the matrices are not square matrices of the same dimension, even more things can go wrong. For example, if I have this matrix with just one column, 1, 2, and a matrix with just one row, 2, 4, and I multiply those together, I'll get a 2 by 2 matrix. That's because this is 2 by 1, and this is 1 by 2. And so the result of the multiplication is a 2 by 2 matrix. But if I change the order, now I have a 1 by 2 on the left and a 2 by 1 on the right, and the result of the multiplication of those matrices will be 1 by 1. Here I have a 2 by 2 and a 2 by 1. The result of that is a 2 by 1. But if I change the order, 1 by 2 and 2 by 2, now I get something that isn't even defined. That's because the first matrix here is 2 by 1, the second one is 2 by 2, and because these inner values don't match, the matrices cannot be multiplied together in that order. So, matrix multiplication is not commutative, but it is associative. What does associative mean? Well, commutative meant that we were going to change the order the matrices were written from left to right. With associative, we're not going to change the order they're written from left to right, but if we've got more than two of them, we might change where we put the parentheses. So we might change which back-to-back matrices get multiplied together first. So with numbers, again, this is a property that always works. If I multiply 3 and 4 together and then multiply that by 2, I'll get the same thing I would if I multiplied the 2 and the 3 together first and then multiplied by 4. So that product is called associativity. Multiplication of numbers is associative, and multiplication of matrices is also associative. That's actually a very useful property because sometimes it lets you take a simpler route to getting an answer in a calculation. For example, let's say I have these three matrices to multiply together. I have two choices. I can either take the two matrices on the right and multiply those together first, or the two on the left and multiply those together first. So what happens then? Well, if I do it the first way, the result of a 1 by 4 and a 4 by 1 is 1 by 1. So then I just have to multiply this 3 by 1 and 1 by 1 together, giving me an answer. But what if I did the multiplication in the other order, where I started with the two that are on the left? Now I have a 3 by 1 and a 1 by 4, and when I multiply those together, the result is a 3 by 4 matrix. Now I'm going to have more work to do in order to calculate the product for a 3 by 4 and a 4 by 1. The result will be the same, but it's going to take more work to get there.